In this video we're going to be creating the objective item that the player needs to run around the maze and collect in order to move on to the next level. Once the player collects these objectives, it doesn't mean it automatically transfers to the next level. It just basically means that the player is able to. What leads to the next level is up to what we do later. So what we're going to do is we're going to get started by creating two classes. We have a Puzz Pickup Factory objective item, which extends from Puzz Pickup Factory. And we also have a class called Puzz Inventory Objective Item, which extends from Puzz Inventory. Please remember there's underscores there, there's no spaces. Obviously, I'm sure you are catching on at this point, but the Puzz Inventory item is actually going to be what the Puzz Pickup Factory creates. We're going to use the same code pretty much inside the give2 function, except we're going to use a different function this time. We're going to actually call on what's known as add objective counter function that we're going to create. And also down below we've changed a few things that are a little different. First, inside of our begin object where it was a static mesh, it is actually now a skeletal mesh. And what that means is that this is going to have some sort of animation that goes with it that's created through an animation tree. So we have skeletal mesh equals skeletal mesh class content dot skeletal mesh dot floating ball, which is where it's located. Then we have a few things that come with the skeletal mesh. We have what's known as an anim tree template, an anim set, and a physics asset. The physics asset's kind of something that probably won't even get really used, but let's say you destroyed this item, or it went into some sort of ragdoll state. The physics asset kind of allows it to do some sort of physics along with it. So it may fall a particular way or things like that. The anim set is actually the animation that this pickup factory has, and the anim tree template is where we put the anim sets to make them work properly, based off of maybe it's depending on the physics of this thing, or it could be if it's walking, whatever. Now obviously this isn't going to be walking, but just to give you an idea, when you're doing an anim tree, usually you base your animations off of particular instances. Everything else is pretty much the same except the collision. We changed the collision a little bit, which isn't a huge deal if you don't change it. In this case, it's not as big, but with other things it may become more of a thing. And also the inventory type, of course, is pointing to our objective item, not to some other item. Once we have all that code in, we go to the Puzz player controller, where we have our variable, that integer objective counter, which is going to hold how many of the objectives we've actually counted, or we've picked up rather. So it's going to hold our counter basically. And then we have what's known as the function that was being called from the pickup factory objective item, right here where it gets called add objective counter, and there we have add objective counter. And what we're going to do is we're just going to add 1 to the objective counter every time we pick up a pickup factory of this objective item type. Now we're also going to move on to the next step, which is where we create our states. So inside of our Puzz game, we are going to add quite a number of variables. We have first the variable integer num objective count, and this is going to hold the number of objectives that were placed into this map. So if the person who's making the map isn't the actual coder, this will allow the code to actually find how many are in there, as opposed to using some static number like we're always supposed to use 10 or something like that. This is kind of creates a little bit more of a dynamic touch, because now the map person can add, the designer can add however many of these types of pickup factories in there, and then the game will decide what the requirement is based off of that. We also have a variable integer objective amount required. Of course, this is what the actual end result is of how many are required. And then the variable constant float, which is a percent objective required, which basically is the percentage that is required in order to complete this level or the levels. Also, finally, we have a variable Puzz player controller, Puzz player, and this is just going to hold the actual player in the game, so we don't have to continuously try to find out who the player is when it comes time to really get this game going. Now, since variable constant float percent objective required is a constant, that means that this cannot be changed once the game starts. We need to set a value to it, otherwise it's just going to be 0 and really serves no purpose. So down in default properties, we're going to set percent objective required to 0.80, which is 80%. And that's basically meaning that we now are going to require that 80% of the num objective count is needed in order for us to actually reach our required amount. Now, if you want to do 100% where they have to get every single one of these, then that's fine too. Or you may later want to change the code around, and we might even change it as well, where we are allowing even the person who's making the map to decide how many are required based off of, because of the certain map, how hard the map might be. The first state we're going to create is a state called setting game. This is kind of our first state, and hence the auto state, which is why, which basically means it's definitely going to be the first state. Auto means that as soon as the game starts and Puzz game is created, it goes into this state and runs this code. If it wasn't auto state, if it was just state setting game, we would have to set this state either in post begin play or in some function to tell the game what state we're in if we wanted to not use auto. Now, inside of auto state we have function begin state name previous state name, and what that is in every single state you have these two functions that you can use called begin state and end state. Begin state obviously is when you first enter that state, and end state is when you're actually leaving that state. It allows you to put in some code to get things rolling. And it also allows you to grab whatever the previous state name is or whatever the next state name is, in case if you want different code to be used based off of where we're heading in which direction. Inside of begin state, we're going to create a local variable called Puzz pickup factory, and it's going to be an objective item just like what we've created here, and it's going to be called Puzz object or Puzz obj. Then we're going to have a check, an if statement check, and it's going to say if the number of objective count is equal 0. And then we have an open bracer, so everything inside of here is going to be held by this if. So if the number of objective count is 0, in other words, if we haven't counted yet, if we haven't actually added anything into this number of objective count, then we want to go ahead and run this loop. The loop basically is a for each iterator, and what an iterator does, depending on which one you use, is it goes through all the actors of that certain type and it counts them up for you, or in our case it counts them up, or it can just access them. So you can make changes to each single one if you wanted to. You could do a for each on all pawns and then make them all go slow, or things like that. So it allows you to manipulate all of the actual objects in the game, depending on what you want to manipulate. In order to do that, we have to access world info because that's where this iterator is located. And that's just another class, and that you're more than welcome to take a look. World info is very important to get to know because there's a lot of good stuff in there. It basically holds the world information. So when you're creating your map, a map designer knows a lot about world info usually. So when you're placing these navigation points in the map, that's basically because it involves that map or the world info of that map. So in case if you didn't realize this, a pickup factory is actually a navigation point. It is actually a spot in the map that the AI will walk to if you want them to. So we have to be careful when we do create our AI to actually make sure they don't pick up these items because we don't want them going for the objective. Okay, so now what we're doing here is we're going to go through and we're going to look for all these Puzz pickup factories that are objective items, and we're going to assign that to Puzz object. Now, we're not actually using Puzz object, but you need that to use this iterator anyway. And then what we're going to do is for every single one of these objects that exist, we're just going to add one to our num objective count. And that's what the plus plus means. It just means add one. Take the sum and add one. After that, after we know how many of these exist, we're going to set what our actual requirement is. Our requirement, of course, is what the objective amount required is, and that is what's equal to the num objective count, which is the number, like I said, of these pickup factories that exist. Multiply that by the percentage that we want the person to collect. Now, because this is a integer, the objective amount required, because we do want them to collect a solid number. We don't need a point of a number. We do want to round this number because we want to get like I said, a solid number of these objectives. So that's what the round function is being used for. It's basically a math function, and it's just going to round it to the nearest. and we have a num objective count times percentage objective required. So if you're using test level 2, there's only 2 objectives. If you didn't use round, objective amount required would actually equal 1 because the integer would shave off the remainder. But because we're using round, it's now going to push it up to 2 because it's above the 1.5 median area. So now we can go ahead and move on from there. The next thing is if the objective amount required is greater than or equal to 1, we want to go to state game in progress, which is pretty obvious in this situation. What we're saying is as long as there's at least one objective to collect, go ahead and go to game in progress. If there isn't, that means the map creator or the designer failed to put these objectives in. Then we're gonna shoot out a log that pretty much warns the game creator that, hey, by the way, this isn't working the way it's supposed to. End state we're not using in this case, but I put it in there because it helps as a reminder that that is still there for us to use if we need to use it, and we may put it to use later on. Next we have state game in progress, and this is where we head to once there is at least one objective. I also want to say that if for instance we run through begin state and in this case the objective amount required is 0 or less than 1, what will happen is we won't go to state game in progress. We'll actually have the log shoot out, and at that point we'll be stuck in setting game. We will not move from this location. So we may want to throw in extra code later, which will say, well, if it is less than 1, maybe it can randomly create some objectives somewhere, or if anything, it could just shut the game down. Whatever, it could do something else. It just depends on what you want the game to do when it runs into this bug. Now, next, like I said, we're back in game in progress. So we have a begin state and an end state, which we're not using at the moment, but this most likely will get some code later. And then we have a function tick, and the tick is basically it's not a second, so you don't want to get confused by that. I mean, it can go as fast as 1/100th of a second, and go, it all depends on your CPU speed. So a tick is basically the speed at which the game updates for you. If you have a very slow computer, obviously it's going to tick slower, as opposed to if you have a fast computer, it's going to run much more smoother. The reason why we put this in tick is because we want this to be constantly checked. If we use the timer, we could set the timer to a fast speed, but really, I mean, we're just doing extra work because we want this to be constantly checked. We want to constantly know whether or not the player has actually collected enough in order to meet the requirement. So what we do inside tick is we create a local puz player controller, which we'll call puz PC, and we're going to say if the puz player is not equal to none. So in other words, if we set this already, the puz player, then to go ahead and do this check, which will say does the puz player, or the player that's playing the game, have enough of the objectives in order to complete the level. If the puz player is not equal to none, if it is equal to none rather, then what's going to happen is we're going to set the puz player. We're going to find him in the game by doing another iterator, which is a for each world info.all controllers. So it's going to look through all the controllers and look for puz player controllers, and then it should only find one since this is a single player game, and then we're going to set the puz player equal to puz PC. If this was not a single player game, you most likely would not want to do this, because what would happen is you'd constantly be resetting puz player equals to the new puz PC every time this loops. Not exactly what you want to do. Okay, now that completes this video up to this point. Once again, it's important to make sure that when you create multiple states that you're able to move between them. Now, game in progress, obviously, we'll probably never need to go back to setting game unless the player dies. So we may find ourselves later making some adjustments to these states. Obviously, game in progress definitely will have an adjustment because this log here, which basically shoots it out for us to see, will be removed and some other code will be added, probably another state as well, which will move us into an end of level state of some sort where we can kind of add up our points, save our information so that when it moves to the next level we have it ready.